Again, we're celebrating Sesame Street today.
Hey, I just got an idea. Would you all like to do some snuffle sizes with me?
Yeah!
Oh, I totally would. But until we get there, we got to first solve out this problem. So we're looking at problem number 6. All right. Here's our linear program problem. We're Morningstar. So we're going to let's focus in a little. There we go. Ish. All right. We want to know, how do we create this feed at a minimum cost that meets the requirements that our customer wants? All right. So here's the information we have. So we have the feed 1, feed 2, feed 3. This is the information given in the problem. And so we want to think about, how do we optimize this function? Okay, so our optimization function, so we're going to be down here, is we need to define our variables. So how much do we amount used in pounds of each one? So is that focused in? There we go. Okay, so these are going to be my x1 through x4 variables. All right, right there. So that's the amount I use in pounds for each one. All right, let's go ahead and box that in so we see what we're looking at. All right, now we want to think of what's the cost for each one. Okay, because this is going to be our objective function, right? So our cost for feed 1 is 25 cents. For feed 2 is 30 cents. For feed 3 is 32 cents. And for feed 4 is 15 cents. And that gives me my total cost to equal, which is my objective function, is the sum product of my x's by the cost per pound. Because my x's are in pounds, so cost per pound is going to give me a dollar amount. So there's our sum product. That's going to be our objective function. All right, so let's make that a little greenish. Okay, so now we have our objective function. Now we need to think of our constraints. Well, the first constraint we should think about is that we need to produce, think of this as the production constraint, and that needs to be equal to the sum of all of our x's. So x1 plus x2 plus x3 plus x4, all right, has to be at least 8,000, all right, because this is what's required. So that's one constraint. The next constraint we want to think about is, put it here, is there's one with corn, there's one with grain, and there's one with minerals. Okay, so with corn, we want to know what's the amount in our blend and what's the amount required. Okay, so the amount in our blend, or the amount required, well, we want to think about this, is 20% of corn, 15% of grain, and 15% for minerals. I want to make those look like percentages, so we have that. And the amount is required is equal to 8,000. I'm going to anchor that times 20%, so 1,600. I can now copy that down, and now that's the amount required of each one. Well, the amount in the blend is equal to the sum product of the x's that I use. Okay, I'm going to anchor that times the amount that are in each amount of feed. Oops, I didn't quite do that right. So let's highlight those, anchor it, comma, the amount that's in each feed. Okay, so that's what we get for there. And now I can just copy and paste this down, such that if I have 10 pounds of each, then I'm going to have 6.5 pounds within that 40-pound bag. I'm going to have, because that's how much we have, that 40-pound bag. Let me use a pencil so we can see. 40-pound bag. 6.5 pounds of that 40 pounds is corn. 6.5 is grain. And 9 is minerals. All right, so now I have to set this up. I just need to go to Solver now. So Solver, my objective is to minimize costs by changing the amounts of each feed that I use, such that the amount required is equal to 8,000, and that the amount in each blend is greater than or equal to the amount required in each one. I click Solve, and here we go. So I'm going to use 4,500 pounds of feed 1 2,000 pounds of feed 2, or about a ton, and 1,500 pounds of feed 4. That will meet my requirements here. It'll allow me to produce 8,000 pounds, and my minimum cost will be $19.50. Well, now let's briefly look to see what our sensitivity report can tell us about this in terms of how we might be able to consult the company. Okay, so here's our sensitivity report. So the way we look at this is we want to look at, first let's look at our shadow prices. Okay, so 8,000 is our constraint of how much is required. Suppose the company, the customer of Morningstar, would say we want a feed with 8,001 pounds. Well, if they wanted one additional pound, that'll cost us about a penny and 25 hundredths of a penny. All right. So if they wanted to increase this by 1,000, then it would do 1, 2, 3. It would raise our cost by $12.50. So we should charge them at least $12.50 to do so. Now the question is, what does this allowable increase and decrease mean? Well, we can increase our constraint up to 1,200, and this shadow price is constant. Or I'm sorry, up to 1,200, which is an increase of 4,000, or rather 12,000, 4,000. So you have to do 4,000 plus 8,000 is 12,000. All right, so we can increase this up by 12,000. That shadow price is constant. If we increase it above 12,000 or more than 4,000, then the shadow price is going to change. So this just tells us the kind of the sensitivity of our shadow price. Well, now let's look at our next shadow prices. So we have corn, grain, and minerals. So the corn says, if I take my right-hand side constraint and increase it by 1 unit, meaning 1 pound. So now I want 1,601 pounds in that blend. It'll raise our cost by 50 cents. But the pounds isn't what the customer's asking. The customer's asking percent. So what if the customer were to say, rather than have my blend require 20%, what if I would require 21%? How does it affect my cost? So I look at my sensitivity report. 1% of 8,000 is 80 pounds. So what I can do is I can take 80 pounds, multiply it by 0.5, and that's going to raise my cost by $40. And it's within my allowable increase where I can interpret that amount. So that's how we can use a sensitivity analysis to provide some information. Now, one thing to note also is this minerals blend. What if they say we want to require 1,300 pounds of the blend to have minerals? Well, one thing we note is our blend already has 1,750 pounds of minerals. So if they increase this requirement, that's not going to increase our costs at all. In fact, it can increase by 550 until our costs are going to change. And that's exactly what this allowable increase says, is raising this constraint is going to have no effect on our costs as long as we raise it by 550 or less. And that there is our answer. So let's go back and do the snuffle shuffle.
Because we have a problem.
What's that, Susan?
Well, kids don't have snuffles.
Oh, that is no problem at all, and I will show you why. There's an exercise that's really fabulous, especially if you're a snuffle among us, but you can use your arm if you don't have a snuffle, and you too can do the snuffle shuffle.
Now, if you keep watching, if you do the snuffle shuffle in the next class, I may provide you extra credit.